Alright, I want to show you a helpful way to think about algebra. I still remember the first time I heard a teacher say this. What he said was that algebra is a lot like arithmetic, except instead of base 10, algebra is base x. Now let me show you what I mean here. When we have a number, like, say, 7,654, what we really mean by this thing is 7,000 plus 600 plus 50 plus 4. Now, so that 7,000 is 7 times 1,000, right? Then we've got plus 6 times 100 plus 5 times 10 plus 4 times 1. Now, we can rewrite 1,000. Remember, we said we're in a base 10 system. That's just the way our system works. 1,000 can be rewritten as 10 cubed. So we've got 7 times 10 cubed. Then we've got 6 times 10 squared. Plus 5 times 10 to the first, right? Plus 4 times 1, remember, is 10 to the 0, because anything to the 0 power is 1. So this number right here can be rewritten as this number. Now let's take the same number in base x. 7x to the third plus 6x squared plus 5x plus 4. You see the similarities between these two numbers? This number and this number both have the same coefficients. This one, since we don't have any coefficients after it, and we're in the decimal system, it just refers to 10 cubed, 10 squared, 10 to the first, and 10 to the 0, where this one just refers to x cubed, x squared, x to the first, x is the same as x to the first, and then 4 is the same as 4x to the 0, right? So that's the connection between base 10 and base x. Arithmetic is doing things in base 10, algebra is doing things in base x. And let me show you why that's helpful. Alright, let's take this problem right here. 3x plus 4 times 2x minus 3. How do you multiply these two numbers together? Well, what you may have learned is something called the FOIL method. F-O-I-L, FOIL stands for front, outside, inside, last. You multiply the front terms together, multiply the outside terms together, multiply the inside terms, and then multiply the last terms and add them together. The FOIL method works, but if we think of this as an arithmetic problem in base x, here's what we'll do. Suppose we had just the problem 34 times 20 negative 3, if we can think about that. 20 minus 3. Actually, for this example, I'm going to use positive numbers, and then we'll move on to negative numbers. Alright, 23. 34, I'll just rewrite that. 34 times 23. Okay. If we were to multiply 34 times 23, we would do it like this, right? 34 times 23. And what we're going to do is we're going to multiply 3 times 4 is 12. And we could move this, we could take this 1 and move it over, but let's not do that. Let's just leave the 12 here. 3 times 3 is 9, but what we really have is 3 times 30 here. So we're going to call that 90. Now, we could add a 0 here, or we could just remember that this number is 20. Put the 0 there. 20 times 4 is 80. And 20 times 3, 20 times 30 actually, is 600. So we have, and then we just add the two together, 12 plus 80 is 92, plus 90, plus 600, so plus 690. And we can add 690 and 92 and get 782. Alright. Now let's try this, doing the same exact thing right here. 3x plus 4 times 2x plus 3. All right, 4 times 3 is 12. 3 times 3x is 9x. 2x times 4, and we can even put our 0 here if we want. 2x times 4 is 8x, and 2x times 3x is 6x squared. And if we add these together, we're going to get 6x squared plus 17x plus 12. All right? Now, if we do the FOIL method, which we've learned, it's really just a shortcut of doing this process right here, which is the same thing that we do here. The goal is to multiply each term by each other term. So the 3 gets multiplied by the 4, 3 gets multiplied by the 3x, the 2x gets multiplied by the 4, and the 2x gets multiplied by the 3x. The FOIL method is just a shortcut. It's a gimmick for remembering to do all of these 4 steps. And over here, the 3 gets multiplied by the 4, we got 12. And I know I wrote things a little bit differently over here, but I can write them, I can do it the normal way too. 34, well, I don't know if you can see that. 34 times 23. The 3 gets multiplied by the 4 to give us 12. And remember, putting the 1 up here is just a way of remembering that we have 10. 12 is actually 10 plus 2, right? 3 gets multiplied by the 3 to give us 9, plus 1 is 10. Then we're going to add our 0 here. 2 gets multiplied by the 4 to give us 8. 2 gets multiplied by the 3 to give us 6. And we end up with 782. So we multiply each term by each other term and then add them all together. That's the exact same thing we did over here. All right. Another way that this plays out, this connection between arithmetic and algebra, with algebra just being arithmetic in base x, is when we do long division. Remember, we can divide, say, 3x squared minus 4x plus 3 by x plus 2. We can actually divide this just like we can divide 349 by 17. Right? The algorithm or process is a little bit more complicated, but it's really exactly the same thing. It's divide, multiply, subtract, bring down, divide, multiply, subtract, bring down. So when we do algebra, remember, we're really just doing arithmetic, but we're doing it in base x instead of in base 10. Now let me show you why, one of the reasons why this is so cool. This is helpful because we can use negative numbers just as easily as we can use positive numbers. If we have 3x plus 4 times 2x minus 3 instead of plus 3, like I had at the beginning before I decided to change it, we can still multiply these. We get 3x plus 4, 2x minus 3. Negative 3 times 4 is negative 12. Negative 3 times 3x is negative 9x. Put our 0 there. 2x times 4 is 8x. And 2x times 3x is 6x squared. Now we can add these together, and we get negative 12, negative x, and then 6x squared. That's our final answer. So we can do the exact same thing with negative numbers as we do with positive numbers. That's one of the benefits of working in this kind of situation.